We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximize, minimize, and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Welcome to the second part of our training. We'll start with fourth session, where we'll discuss Azure Storage. In our fifth session, we will focus on identity, access, security, and cost management in Azure. Finally, in our last sixth session, we will delve into management systems, compliance, Azure Resource Management, and Azure Monitoring. Let's begin by familiarizing ourselves with different storage services. You will learn about Azure Storage Account and how it relates to various available storage services. We will also discuss blob storage tiers, data redundancy options, and ways to move data or even entire infrastructures to Azure. And now, let's dive into our data storage, starting with storage accounts. A storage account provides unique namespace for data in Azure Storage Services, accessible from anywhere in the world via HTTP or HTTPS protocols. Azure Storage Account contains all data objects of Azure Storage Services, large binary objects or blobs, files, queues, and tables. Data in a storage account is protected, highly available, reliable, and scalable. When creating a storage account, you first need to choose an account type. The account type influences the storage services and redundancy options, affecting the way you can use it. But what do I mean by redundancy options, you might ask? In Azure Storage, multiple copies of data are always stored to protect against planned or unplanned events such as hardware, network, or power failures, natural disaster, and more. Redundancy ensures that your storage account meets the target availability and durability even in the event of failures. When deciding on the best redundancy option for your scenario, aim to find the optimal balance between cost and high availability. Locally redundant storage (LRS) replicates data 3 times within a single data center in the primary region. LRS ensures object durability of at least 99.999999%. That is 11 nines over a given year. LRS is the most cost-effective option and provides the lowest redundancy level comparing to other replication choices. While LRS protects your data against server and disk rack failures, in the event of data center disaster, such as a fire or a flood, all replicas of the storage account using LRS might be lost or not recoverable. Zone redundant storage (ZRS) ensure object durability of data in Azure Storage Services of at least 99.999999999 12 nines over a given year. For applications that requires a high level of reliability, you can also copy data from your storage account to an additional region located hundreds of kilometers away from the primary region. If you copy your storage account data to an additional region, it remains resilient even to catastrophic failures that could make data recovery in the primary region impossible. When creating a storage account, you choose the primary region for the account. The additional paired region is based on Azure region pairs and cannot be changed. Azure Storage offers two options for copying data to an additional region: Geo-redundant storage, GRS, and Geo-zone redundant storage, GZRS. GRS is similar to having LRS in two regions, while GZRS combined having ZRS in the primary region and LRS in the additional region. GRS performs synchronous data copies 3 times within a single physical location in the primary region using LRS. Data is then asynchronously copied to a single physical location in the additional region pair using LRS. GRS ensures object variability of data in Azure storage services of at least 99.999999%, that is 16 over a given year. Geo-zone redundant storage, GZRS, combine high availability from zone redundancy with protection against regional failures via geo-replication. Data in the GRS storage account is copied to 3 Azure availability zones in the primary region, as well as replicated to an additional geographical region using LRS for protection against regional disasters. Microsoft recommends using GZRS for applications that require the highest consistency, resiliency, and availability, along with excellent performance and disaster recovery capabilities. Now let's visually compare our redundancy option. For regions supporting availability zone, locally redundant storage performs synchronous data replication across 3 Azure availability zones within the primary region. Zone redundant storage replicates data within a single region across different data centers. Geo-redundant storage replicates data 3 times within a single physical location in the primary region using LRS. Then, the data is asynchronously copied to an additional physical location in a secondary region. Geo-zone redundant storage copies data to 3 Azure availability zones in the primary region, similar to ZRS, and replicates it to an additional geographical region using LRS. Now that we have covered data redundancy, let's move on to data services. The Azure Storage Service Platform includes the following data services: Azure Blob, Azure Disk, Azure Queue, Azure Files, and Azure Tables. Azure Blob Storage is a solution for storing objects in the cloud. It can store large volume of data, such as text or binary data. Azure Blob Storage is unstructured, meaning it can contain various types of data. It can handle thousands of parallel uploads, large video or image data, constantly growing log files, and is universally accessible with an internet connection. The second type of data service is Azure Disk Storage or Managed Disks, which are block-level storage volumes managed by Azure for use with Azure virtual machines. Essentially, they function like physical disks, but virtualized for added resilience and availability compared to physical disks. With Managed Disk, you only need to prepare the disk, and Azure takes care of everything else. The third type of storage is Azure Queue Storage. It's a service for storing large numbers of messages. You access messages from anywhere in the world via authenticated calls using HTTP or HTTPS. A queue may contain millions of messages, up to the total capacity limit of a storage account. Queues are commonly used to create a backlog of work to process asynchronously. The fourth type of data service is Azure Files, which provides fully managed shared file resources in the cloud accessible via standard industry SMB or NFS protocols. Azure files can be simultaneously connected to cloud and on-premises deployments. SMB shares of Azure files are available for Windows, Linux, and Mac OS clients, while NFS shares are available for Linux or Mac OS clients. And finally, Azure Table Storage is a service that stores non-relational structured data, also known as structured NoSQL data, in the cloud, providing a key attribute store with a schema-less design. You can use table storage to store flexible data sets like user data for web applications, address, books, device information, or other types of metadata your service requires. You can store any number of entities in a table, and the storage account may contain any number of tables, up to the capacity limit of a storage account. On this table, you see the public endpoints of storage services: blob storage, data lake storage generation 2, Azure files, queue storage, and table storage. Your storage account's flexibility doesn't stop there. It's also equipped with different access tiers, tailored to accommodate a variety of data storage scenarios. The Azure Storage Service offers different access tiers for storing blobs, providing the most cost-effective data storage options. The possible access tiers are hot, cool, cold, and archive. The hot storage tier is optimized for frequently accessed data, such as images for a website. The cold storage tier is optimized for infrequently accessed data stored for at least 30 days, such as customer invoices. The cold tier is an online storage option optimized for data that is infrequently accessed or modified. Data in the cold tier should be stored for a minimum of 90 days. The cold tier has lower storage cost and higher access cost comparing to the cool tier. The archive storage tier is intended for rare access data stored for at least 180 days, with relaxed retrieval time requirements, such as long-term backups. When your data is stored in an online access tier, whether hot, cool, or cold, users can access it immediately. The hot tier is the best choice for data that is in active use. The cool or cold tiers are ideal for data that is accessed less frequently but still needs to be available for reading and writing. While cool data comes with a slightly lower SLA for availability and higher access costs comparing to hot data, it's a reasonable compromise considering the lower storage costs. In archive storage, data is offline, which provides the lowest storage cost but comes with higher cost for data retrieval and access. As mentioned before, data must remain in the archive tier for at least 180 days, and early removal will incur charges. While a blob is in the archive tier, it can't be read or modified. To read or download a blob in the archive tier, you must first rehydrate it to an online tier, either hot, cool, or cold. Data in the archive tier can take up to 15 hours to rehydrate, depending on the priority you specify for the rehydration operation. Now, let's finally take a look at our storage services directly on the portal. In this demo, we will see how to create a blob and a storage account. If we want to upload a blob, we will need to have a storage account, so it will be our first step. Right, we will need to find a service that is called storage account. Use the plus button to create a resource as we did in previous demos. We'll select create. And we'll need to provide the information about subscription and resource groups. We can use the resource groups that we created during our VM creation. And after that, we will need to provide a storage account name that is global and unique. Also, it will be informed in this info box, so the name must be unique across all existing storage account names in Azure. It's very important, otherwise you can't create a storage account. So I will create one. No contoso with Alexandra. Long name to be sure that it's a unique one. And it works now, you see. I can continue. I will keep the same region that is close to me. And I can also select performance. Is it standard or it's a premium one that I would like to have? If I need a low latency, I will go with standard. And I will need to select redundancy option. I have all redundancy options that we discussed: LRS, GZRS, ZRS, and GZRS. I will select LRS, it is less expensive one, and I'm using the storage account just for a demo. I have also different advanced options for security that you don't need to know to pass AZ900 exam, but you need to know that you have extra feature if you want to enhance your security. After that, we have networking. I will keep by default that I want to have a public access from all networks, but if I want to have access just from selected specific virtual network, I can select it here, or if I want that just some IP addresses can access my storage account, I can also modify it on this page. We have a data protection option that is very interesting because we have a soft delete. Soft delete means if I delete some element or some blob, it will be kept for 7 days in my trash bin. So by default, it's 7 days, and it helps to protect the data from accidental deletion, for example. And if you want, you can modify the number of days on this page. We have also encryption. If I want to go, for example, for custom manager keys for encryption, no worries, again, it's a bit out of scope of AZ900, but you have those advanced options here. We have tags as we had them on previous resource creation, and in the end we have review, and we can create our storage account. Let's hit create, starting the deployment, and usually it will take 1-2 minutes to create your storage account, and after that we can go inside and create our container to add a blob inside. So deployment is in progress. Let's wait a bit. Wonderful, our resource is created. Let's go to our storage account. So here we have an overview, and as well we have data storage with 4 different options that we saw on our deck: containers, file shares, queues, and tables. For blob creation, we will need to use containers, so we'll select in data storage containers and add a new container via our plus button. Let's select a container and provide a name to it, AZ900. And we have different public access level: private, no anonymous access, blob, anonymous read access for blobs, or containers where we give anonymous access for read to our containers and to our blobs. I will use a private one, and if I want, I can also set up encryptions, extra capabilities in advance, but for the simple demo, I will just select a private public access and create my container. After, I can go inside of my container and upload a blob inside. I will browse for files. Here I have one blob that I prepared, and I will click upload. So we have successfully uploaded our blob, and now let's say we want to share it. I have an URL link here to my blob, but if I would like to share with some external users, as it's in private access, I will need to generate a key. You see, I have here a SAS. So if I would like now to share it with someone out of my organization to see this image, I will use generate SAS, and I can provide just in time access to my blob in private access. So it's very important to select the permissions. I will give just read access to this blob and select when I'm giving access, and I can generate a SAS token to have temporary access to this image outside of my organization. And to test it, let's open New in Private tab and try to access our image. And here we have a beautiful statement: keep calm and configure Azure. It's what we're learning together today. So thank you for your attention to this demo. We saw together that we need first to create a storage account. After that, we will create a container and upload blob inside, and we can share it thanks to SaaS for a specific amount of time. Thank you for your attention. Let's come back to our presentation. Transitioning from the exploration of storage access tiers, let's shift our focus to another pivotal facet: migration to Azure. This seamless transition is empowered by the robust Azure Migration Service, offering an unified solution for migrating, modernizing, and optimizing resources. All pre-migration stages, such as discovery, assessment, and right-sizing of on-premises resources, are incorporated into the infrastructure, data, and applications. The scalable platform of the Azure Migration Service allows for the integration of third-party tools, expanding the range of supported use cases. The Azure Migration Service acts as a centralized management hub for assessing and migrating on-premises data centers to Azure. It offers a single portal to initiate, execute, and track the progress of migration to Azure. The Azure Migration Service integrates with other Azure services and tools, as well as offering from independent software vendors. Through the Azure Migration Center, you can assess and move your on-premises infrastructure to Azure. Azure Data Box is a physical migration service that enables fast and reliable transfer of large volume of data with minimal costs. The secure data transfer is facilitated by delivering the data box storage device with a maximum capacity of 80 terabytes. Data box is transported to and from the data center through a regional transportation service, and its reinforced casing protects it from damage during transportation. You can order the data box on the Azure portal to import and export data to and from Azure. Once the device arrives at your data center, you can quickly set it up using a local user interface. After completing the data transfer to or from Azure, simply return the data box. When transferring data to Azure, the data is automatically sent back to Microsoft after they receive the data box. The entire process is managed through the data box service on Azure portal. Databox is ideal for transferring data exceeding 40 terabytes when network connectivity is limited or unavailable. Data movement can be a one-time, periodic, or initial bulk data transfer operation followed by periodic transfer. In addition to large-scale migration using services like Azure Migration and Azure Data Box, Azure also provides tools for moving individual files or small files groups and interacting with them. These tools include AZCopy, Azure Storage Explorer, and Azure File Sync. AZCopy is a command line utility that can be used to copy blobs or files to or from a storage account. With AZCopy, you can upload, download, copy files between storage accounts, and even synchronize files. AZCopy can also be configured to work with other cloud service providers to move files between clouds. The second service in the center of my screen is Azure Storage Explorer, which is a standalone application that provides a graphical interface for managing files and large binary objects in your Azure Storage account. It works on Windows, macOS, and Linux and uses AZCopy on the server side to perform all files and blob management tasks. With Azure Storage Explorer, you can upload data to Azure, download the data from Azure, and move data between storage accounts. And The third service in the right side of my screen is Azure File Sync. It's a tool that centralizes shared folders in Azure files while maintaining the flexibility, performance, and compatibility of a Windows file server. It's almost like transforming your Windows file server into a miniature content delivery network. Once you install Azure File Sync on your on-premises Windows server, the service will automatically keep your files in sync with your Azure files. With Azure File Sync, you can maintain any number of caches you need in any region of the world and replace a failed on-premises server by setting up Azure File Sync on a new server in the same data center. Additionally, Azure File Sync allows you to set up cloud tiering, where the most frequently accessed files are kept locally, while less accessed files are stored in the cloud until requested. That concludes our fourth session. Let's recap what we have learned in it. Firstly, we learned about storage account and how to compare Azure storage services such as containers, files, and disk, as well as how to describe storage tiers and redundancy options. We explored locally redundant storage, LRS, geo-redundant storage, GRS, zone redundant storage, ZRS, and geo-zone redundant storage, GZRS. After this session, we can identify migration options, including Azure Migration and Azure Data Box. And at the end of the session, we learned how to describe file movement options, including AZ Copy, Azure Storage Explorer, and Azure File Sync. Thank you for your attention. You have earned a 10-minute break to rest and recharge for our fifth session on identity, access, and security. Enjoy your break.